Everyone. Thanks Jason, and thanks to PromptWorks and Philly Tech Week for hosting me. I'm pretty honored to participate. I think the panel and Hector are a pretty tough act to follow, but I'll do my best. Like Hector, I'm going to be speaking specifically about a technology versus the panel, which sought to cover this broader topic of craftsmanship and philosophy surrounding that. But hopefully I'll weave in some of that philosophy and underscore its relevancy in my mind to the theme today, Senior Dev Day. I think maybe a key difference between Hector's talk and mine is I think Hector knew what he was talking about. So I'll let you guys decide, where naivete becomes me being an imposter. So again, my name's Mike Ball, and I work for Comcast here in Philadelphia. I work on a team that's responsible for a suite of video streaming and TV delivery applications. And so again, what's the relevancy here to this theme of Senior Dev Day? I think historically, Comcast hasn't always had the best reputation in terms of quality and customer service, and that's part of what my team and my corner of Comcast is tasked in changing, and then more specifically how that relates to this broader question of what constitutes senior developer responsibilities. I know in reflecting on my evolving roles over time, what taking on more and more senior responsibilities has meant is being responsible for more and more of the full application stack beyond just the application level. So included in that being infrastructure and all the surrounding services like DNS and servers and the network layer. So that's kind of what brings me to Terraform. I want to try and share with you guys a little bit of how Terraform, this specific tool, has helped in this number one effort towards quality for my team, and number two, my increasing responsibilities through the full stack, including infrastructure. My team's responsible for a lot of infrastructure, and we're increasingly responsible for more infrastructure and not less. And so these questions of how do we manage all of that, how do we operate it, and how do we ensure that it's functioning with quality is pretty pushed to the forefront of concerns for us. So what is Terraform? This is lifted straight from the Terraform website, just a quick overview. Terraform provides a common configuration through which infrastructure can be launched. So included in that is everything from physical and virtual servers to email and DNS providers. And this was built by a company called HashiCorp. And I should mention, if anyone didn't catch it, that Justin Campbell works for HashiCorp. And they're responsible for a few tools in this suite of products, including Vagrant, Console, Packer, a few others. So Justin, you feel free to heckle me if and when I get something wrong. I think Justin's probably far more qualified to speak to this than am I. So given that definition, what exactly does that mean? We're going to kind of drill into some specifics here, and I'll offer a quick demo, and then I'll kind of discuss some peripheral things related to Terraform. So it might feel a little schizophrenic, but bear with me. So again, what does this definition mean? So Terraform provides this tool through which we can build, change, version infrastructure through a common configuration file. This allows us to codify everything from physical hardware through to VMs to email and DNS providers, and to do so with multi-cloud or multi-provider support. So I'll drill into the specifics there, but just hold that thought. So how's it work? The basic components of how Terraform works are through number one, a .tf file, and number two, through this Terraform CLI. So the TF file allows teams to describe their infrastructure, to describe what infrastructure they want or need to exist to operate software through a simple DSL. And then the Terraform CLI provides a way to interact with this TF file to create, change, and destroy infrastructure accordingly. So what's that look like? Again, this TF file, here's an example. This is authored via this HashiCorp configuration language. So again, a simple DSL for describing resources. In the case of this example, we've got two resources, DigitalOcean droplet being one, and then a DNS simple record being the second. And then as for the CLI usage, there's a suite of commands, suite of actions that can be executed, but the primary three would be plan, apply, and destroy, which respectively execute or allow a user to view an execution plan, actually execute the plan, and in the case of a destroy what's spec'd in the TF file. So again, there's more commands, but those are the three basics as scoped to this intro. And then that all works in concert with this TF state. So the TF state saves record of the Terraform action in a JSON file. So the current state would live in a TF state file, and then Terraform will automatically back up the previous state in a backup file. So that's obviously offers a pretty great path towards quick and easy rollbacks in the case of an unintended or problematic change. And so this create, read, update, destroy lifecycle works with plan and apply, resolving what is requested with what exists using a combination of the TF file, various provider APIs under the hood, and TF state. And what I mean by what is requested here is what is spec'd out in the TF file. So how to actually use this tool, how to use Terraform to safely orchestrate infrastructure changes. I think within this umbrella of question, there's a few sub-questions. How does such change get coordinated across a team or across an entire company? Taking the example of Comcast, we have thousands and thousands of software engineers and hundreds of data centers, and don't quote me on that, but that's at least my perception of the data center account. It's beyond human comprehension is a pretty safe answer. And then how do we guarantee safety, and how do we is there any way that we can leverage continuous integration or continuous delivery, a topic touched upon by the panelists as an important part of ensuring quality? Is there any way we can leverage that in working in concert with Terraform? So my thesis statement here is that Terraform, working together with software engineering best practices like Git version control, code review, continuous integration, a lot of the practices outlined by the panelists in speaking to craftsmanship offer a powerful path towards full stack quality beyond just the application level, but also including infrastructure. So I've got an example I've doctored up. This is on my GitHub, username MDB, and the repo name is Terraform-example. This is a basic example that's going to demonstrate continuous delivery through Terraform executed by Travis CI. Travis CI being the popular and free to open source projects CI solution that integrates pretty elegantly with GitHub. And so what this repo demos is that a pull request and a merge to master of this repo turns mikeball.me, which is a domain name I recently bought, from a non-existent website and just source code through to a functional website. So a little bit of what's going to happen here. Before the Travis CI build, you can see this is my proof. screenshot, that this website didn't previously exist. So my ideal would be a live demo that takes non-existent website through to functioning website. I'm not going to do that because that sounds terrifying. And we would also have to wait for DNS to propagate. So that would not be the most exciting demo. But after the Travis CI build deploy, we get a functioning website. In this case, just a simple index HTML file that returns the text, hello. So how'd this happen? So we merged what I'm calling this Genesis PR, a pull request that created the world in this case being this .me website. We merge that, and then Travis CI creates the website by building and deploying. So we can take a quick look at this Travis CI log output. So I'll drill into this in a little bit more detail, but for now, we'll just skim. So trust that we're doing some stuff. We're building a collection of static HTML, CSS, and image files from source code. And because this is a change to the master branch, we advance on to this deploy stage where we deploy the application via Terraform. So here you see some examples of Terraform output. This is the plan output. So I'm just going to skim over this, but we'll drill into specifics in a bit. And then eventually that plan is applied, it takes effect, it creates in the case of this example, some AWS resources that enable this simple mikeball.me website, and in the process generates a TF state that gets committed back to the repo where it lives in version control. All right, so some details. Who, just so I can kind of gauge detail, how much detail I go into appropriately, who here is familiar with Travis CI? Yeah, I figured a lot of folks probably were. So I'll try to make it brief, but the way Travis CI works is to wire up to a GitHub repo, a webhook in Travis CI that monitors changes to the repo, and then executes continuous integration on Travis CI's infrastructure as is spec'd in this .travis.yaml file. So this is the set of instructions I provide Travis CI to tell it what to do when I've pushed a change to this repo. So we're telling Travis CI, give us a Node.js container, telling it which version of Node to provide me. I'm establishing some environment variables that I'm going to use later. An important one being my encrypted GitHub API token and AWS creds. Travis CI provides a mechanism by which we can encrypt these credentials so they're not publicly exposed. I'm installing some dependencies for building the software, and then here I build the software, which again just takes source code and compiles to static HTML in the case of this simple example. And now, moving on, you can see we've got a before deploy and a deploy step. Note that this only takes effect on changes to the master branch, such that if a pull request is open, or if a team member, obviously this is just my personal repo, but I think you see the applicability to a team scenario, were to push a change to a branch that doesn't actually get deployed. We're only deploying changes to the master branch. So before deploy, I'm leveraging this Travis CI lifecycle before deploy hook to actually install Terraform on the Docker container performing the build. That's something that Travis CI doesn't provide us for free. And then I advance on to this deploy stage where I'm executing a deploy shell script. So what's going on in that shell script? That's basically a wrapper for these Terraform actions that I wrote. So let's take a quick tour of that one. So you can see here, simple shell script. I'm executing Terraform plan. I'm executing Terraform apply. Committing the TF state changes and pushing them back to master. And then finally, let's take a tour of the main TF file. So as I mentioned previously, this TF file is where we spec out the resources or the infrastructure resources required of this software, which again is basically is a basic static website. So this is what that main TF file looks like. Again, this is written in that simple HCL configuration language. So you can see here I'm establishing some variables. I'm declaring the provider, in this case, to be AWS. I set up an S3 bucket. I give that bucket a policy for serving static website content. I set up a second www bucket, which redirects to the first. So that would redirect www.mikeball.me bucket request to mikeball.me. I'm sticking some objects in the bucket. So here's the index.html document, a CSS file, an image file, and then here I'm configuring some DNS. So I'm establishing an AWS Route 53 zone for this domain name, this .me domain name, and I'm establishing a record for it as well. So what about making a change? So here I'm going to take a gamble, and we'll try to make a change to this infrastructure, and maybe my career will crash and burn, or maybe it'll work. So I've opened up a pull request, and I've reviewed my own pull request. Looks good. So you can see here the only change is we're going to take what was previously this simple website serving back a single header that reads hello to now source a CSS file. So I think those changes look good. Let's roll. So I'm going to merge that, and let's take a look at Travis CI and watch her build. Oops. There you go. So it looks like we're stuck in the Travis CI queue. Not surprising. Okay, so we'll just hang tight, but I'll describe to you what will happen when it does happen. Again, we're going to build the software, which requires installing some dependencies and compiling what is Node.js source code into a static HTML website. And in this case, because I've changed some of that source code, we're going to generate a new index.html file. Terraform will detect that that's a change I've introduced to this index.html resource and deploy. So here we go. So we're setting some stuff up, and yada, yada, yada. So we're going to install Node 6, because I've declared that as a dependency. We've installed these Ruby gem requirements that are required of compiling Sass to CSS. We move on to installing Node dependencies via npm install. So this should take a second. When this completes, we'll actually build the software, and then because this is a change to the master branch, we'll advance to that deploy stage, and that's where Terraform apply takes effect by proxy of this deploy sh script. So I think in the interest of time, well, this is moving. It's fun to watch log output, right? Okay, so we're compiling templates, compiled style sheets. By the way, I've never tried this, so hopefully this will work. So we're installing Terraform because we've detected, Travis detected this is a change to the master. We've advanced onto the deploy stage. So here you can see that Travis CI Terraform detected some changes to my S3 bucket. So you see we've detected 3 changes. And we're going to actually eventually apply those changes. And we finished. So you can see here, we advanced through apply, the TF state changed, and we committed those changes back to the repo. So let's now refresh this. And ooh, it's a good opportunity for HTTP too, huh? So this is, I live in West Philly, and this is just a CSS animation of some illustrations I made. I'm always pretty stoked about all the West Philly architecture and vibe out on the trolley, cruising to work in the morning, checking it all out. And so these are just illustrations I made inspired by that. So that was obviously not the most infrastructure intensive change to have made, but hopefully you see my point as to how this could apply to more ambitious changes like scaling out servers or upgrading servers or configuring DNS or establishing additional AWS resources like Lambdas or EC2 instances. So you saw that now works. So why all this? What's the alleged value here? Again, the point I want to drive home is that I think this offers a pretty powerful a quality insurance technique. And so through codified infrastructure that's managed just like we manage our software source code, and where code reviews and things like continuous integration are in place to ensure quality checks before changes meet customers, we can guarantee quality at scale. Change becomes cheap and repeatable, by which I mean it's safe and easy. We're just changing source code, the result of which is actual infrastructure change when it's merged. That happens in an automated fashion. And I think Terraform is a pretty compelling tool towards this goal, especially in that it provides this easy to read declarative DSL and saves operators of this infrastructure or application developers from having to write custom business logic. Much of that is pushed under the hood in Terraform via these CRUD actions I described. And then last, we get state backups, which is pretty powerful. So the state of infrastructure is itself lives in this ongoing record that could be version controlled. So some more advanced usage. This Terraform example repo is also obviously pretty simple, but hopefully painted a picture that allows you to imagine how we could layer in some more sophisticated delivery on top of CI. Maybe one thing worth pursuing could be to leverage blue-green deployments where we deploy to a dark endpoint, execute some live functional tests, ensure that everything is operating as it should before toggling the new deployment active. Or you could maybe even imagine how we could create some pipelines that rather than blindly deploy master to production, promote code changes through lower level environments and then on to production where customers will meet them. So some more stuff about Terraform. So this is some of the more schizophrenic peripheral things I'll point out. A few notes about Terraform versus other tools, which I think help bring into focus the exact use case here. So tool category number 1 would be API client libraries. And these differ from Terraform in that they provide some low-level programming APIs versus Terraform, which is this high-level syntax for describing resources. So in the case of API client libraries, you'd be writing code like this. This is a Ruby Fog example where we're actually executing and exercising conditional logic. So business logic, in other words, versus Terraform, where we just we describe the resource we want, and under the hood, Terraform in concert with the TF state and in concert with all of the CRUD actions implemented on a provider, the provider in this case being AWS, exercise the necessary business logic. So we're saved from having to reinvent the wheel there. Tool category number 2 would be config management tools like Chef and Puppet. I think these tools are often tasked with managing software and configuration on individual machines, and oftentimes they assume those individual machines already exist, versus Terraform, which aspires to address things at a higher level data center abstraction. So config management is kind of good at turning this, so a naked box, into, for example, this. Some flavor of a server running some flavor of Redis. Versus Terraform, which I'd make the argument is good at turning this, so nothing, into a landscape. And doing so by working in concert with these config management tools to address installations of different software on the individual machine level. And then finally, tool category number 3, I think these tools, AWS CloudFormation and OpenStack Heat, for example, are most analogous to Terraform. These are tools that allow teams to describe the infrastructure landscape they want, but I think they differ from Terraform in an obvious way. Terraform aspires to be multi-provider agnostic versus these tools, which are provider specific. So, for example, Heat is good at making this happen in a single provider, in this case the provider being OpenStack, versus Terraform, which I think is good at making this happen. So gluing together infrastructure that can straddle multiple providers. In this case, we're leveraging OpenStack, we're leveraging Amazon, and we're also leveraging DNS Simple to create a functioning system. So I won't go into too much detail, but you can browse the Terraform source code and see that the built-in provider support is pretty exhaustive. A lot of the obvious players are present, so AWS, DigitalOcean, Heroku, OpenStack, etc. But glossing over that, a few other points of note. Terraform does also support this concept of a remote state. In my demo, I committed the TF state back to the source code repo. But Terraform also supports remote state. And this could be helpful in helping distributed teams coordinate state for various shared dependencies. And it also provides a good way to make sensitive data, to keep sensitive data from making its way into source code repositories in the event that any sensitive data does end up in the TF state. So you can read a little bit more on Terraform's website about remote state, and you can see here that some various backends are supported, including S3, Artifactory, Atlas, Console, etc. So there's that backend list again. And then another great feature is custom providers. So this is something I've found pretty beneficial. This is a tiny screenshot that Justin Campbell gave me. This is a quote from Paul Hinz, who's a Terraform contributor. Here's the quote in some more legible size. So Paul Hinz, who's a core Terraform contributor, said, if it's an internet accessible API that can be modeled declaratively, it can be terraformed. And I think that's a pretty good takeaway there. So Terraform does support the ability to author custom providers, and that's something I've found beneficial. So I think you've probably inferred what a provider is. It would be AWS, Heroku, OpenStack, for example. So this is one of these providers is responsible for the life cycle of a resource, the create, read, update, and delete actions. And I've found on my team that writing your own provider offers some pretty big benefits. They offer the ability to terraform internal services, so services that may be specific to your company or your organization. And in doing so, you can abstract away all the ad hoc per team business logic that often gets written to a shared provider. So that would be that provider would house all of the CRUD action logic, thus saving teams from having to write their own, again, reinventing the wheel. And this also provides a pretty great technique in my I would argue, in ensuring against vendor lock-in, because changes to these TF files are so cheap and so easy. It's not a refactor of business logic code and surrounding unit or functional tests. It's just a config file change. So that's pretty powerful as well. And you can read more about custom providers. Terraform provides some documentation in there. By the way, these slides are up on mdb.github.io/terraform-presentation if you want to follow along. And then finally, I'll cover some quick gotchas. I mentioned that sometimes sensitive data could get into TF state, so you want to be aware of that and protect against it. I've had some bad experiences where infrastructure is edited outside or changed outside of Terraform, and that can get a little confusing. That isn't to say Terraform can't handle it or that you can't strategize how to deal with this as a team, but you'll need to think about that because it can and may, because it can happen, it may happen, and if and when it does, it could also yield unintended consequences like downtime. And that brings me to another point. Destructive actions can yield downtime, so you want to be really careful about that. And then I'll also offer a quick confession. In setting up this example repo, I discovered what I believe, is a Terraform shortcoming, wherein Terraform / its interaction with AWS didn't ensure that the DNS servers associated with my .me domain name matched those associated with the A record I created, so I actually did have to manually edit those. Terraform could be capable of doing that, and that's a pretty good PR opportunity, so maybe I'll get to that over the next couple of days. And then, sorry to be another voice broadcasting this message, but I'll make it quick. My team is hiring. Here's some keywords for different technologies we work with. If there's any of that stuff excites you, feel free to reach out to me and we can talk more. But as for the meat of the presentation, that's it. I'm happy to take some questions. Yeah?
How does Terraform deal with the pets in your database, or the pets in your infrastructure, the ones that aren't cattle?
Yeah, that's a good question. So the question is, how does Terraform deal with the pets in your infrastructure versus the cattle? The metaphor there being, I'll try to paraphrase, tell me if you think I got this wrong, the servers or the elements of infrastructure that are kind of manually managed versus those that are treated as disposable resources and managed via source code. Yeah, it kind of doesn't. I think the goal would be to make it responsible, to minimize the pets and make everything codified and managed via source code versus long-lived managed pet.
So you just have like a configuration policy. This is what a pet moves. Not much more than that.
I guess you could make note of such a thing in source code comments, but my goal is to refactor such things out of existence, such that everything is codified. That's a pretty noble and ambitious goal in a company as large as Comcast, and I'm not responsible for all corners of Comcast. I can only speak to the software and the infrastructure that I am responsible for, but yeah, that is the ideal goal. Any other questions? Yeah.
So Terraform looks like it handles a lot of providers. What are my assumption is that there are trade-offs for being able to do everything. Like, are there things that it just can't do, or can't, like the features of certain providers that it just can't handle, or are just not going to be cross compatible with each other?
Gotcha. So the question is, are there any known and obvious Terraform shortcomings in handling certain provider resources?
Right.
Is that an accurate paraphrase? Yeah, I'm sure there are. I think the GitHub issues would probably be a good place to dig into that, and I can speak to the one I discovered, which was that there does not appear to be a Terraform AWS resource for registered domains. There was only a resource when I created the code for my demo covering Route 53 zones and records. But AWS does provide an API interface to registered domains, but Terraform does not have that resource baked in yet. So that would be a good example for jumping in and creating it and submitting a pull request. Is that a satisfying answer?
Yes.
Cool. Anybody else? Yeah?
If there are certain things that you can't do in Terraform, can you have a script, a Python script or something else that you can call to, and are there hooks like before and after actions that you can call at particular times with your own scripting?
Yeah, you can. And in the case that, yeah, so you could call out to scripts, and Terraform also has a concept of provisioners. Am I correct about that?
Yeah, so each resource can have a provisioner, and every resource inherently supports local exec, which could run any script in your directory or whatever. And then for resources that Terraform can like SSH or other protocol to, there's also a remote exec where it can actually, if you're spinning up like an Amazon Q instance, they can SSH into that instance and run a script when you start it.
Yep. Thanks for taking that one, Justin. All right. Any other questions? Okay. Thanks, everyone.
Okay, great. We'll take a brief minute to turn things around, and then we'll start our design panel.